Hey. Hi. Can we be pals? Can we be friends? No. I'm Mr. I just say I'm Mr. K. But you know what that stands for, don't you? Oh yeah, Mr. Key. Because I'm here to give you the answers to all of your life's problems. But before I do that, by the way, I made another video this morning. I'm feeling a lot better since that one. That one I sounded like a frog. This one I just sound, I don't know. I don't think I'm going to cough as much. Let's take out the highlighter. We might need that. A colony, a growth. So since we're seeing growth, by the way, if you haven't hit the subscribe button and you're borrowing my stuff, you might want to hit the subscribe button. By the way, if you're just stealing all the stuff my friend and a colleague of mine have made, you might want to throw us a bone. I'm going to put a link to her Teachers Paying Teachers site because she has lots of cool stuff up on there. You could hook her up. And, you could throw me a bone too. How much work am I saving you? Anyway, let's get started. We've got a growth of colonies by this formula. Now, you'll notice it's growth because this number in the parentheses is bigger than 1. This actually has lots of growth, like huge growth. We'll see. G is the final. G is final. I is the initial. And this says how many hours will it take for a colony starting at 25 to increase to 25,000 cells. Round answer to the nearest whole hour. Ew, not a problem. So we're going to end with 25,000. That's G. That goes on the left side. We're going to start with 25. And we've got 3.1.226 T. So, just as a reminder, we're going to isolate the weird thing. Now, this thing here is the weird thing because it has the exponent that is a variable. So, we need to get rid of the 25. Let's see, 25 into 25,000. Gee, I wonder if that's 1,000. So, 1,000 is equal to 3.1 raised to the 0.226 T. It's all about that bass, about that bass, about that bass. It's all about that bass. Gosh, I'm glad that girl whoever that is, came up with that crazy song. At any rate, we're going to turn it into a logarithm. So log, keep the base, all about that base, and then these two things just switch. So you have to somehow magically get that t out of being an exponent. We do that using logarithms. And then my final step will just be divide by 0.226. Divide by 0.226. Bust out the old Taschenrechner. Then we're going to do control log 3.1 of a G. G. And then whatever that is, we're going to divide that by 0.226. 27.015. So T equals 27.015. So T is equal to 27 hours. Done. Moving on. The growth, again, we got growth, and look, it's bigger than 1. We've got growth of a colony of strain of bacteria is by that equation. We want it to reach this. We're going to start with this. So here we go. 3,200 is equal to 7 times 2.4 to the point 621. Should be a T up here. Sorry, I had to bring up the original document. See, the T's missing. I don't know why it's missing. I just want to triple check. Okay, so 621T. No big deal. Divide by 7. Divide by 7. So now I'm going to get, see, I don't know what this is. I don't know what 3,200 divided by 7 is. I have no idea. Doesn't even matter. So let's see here. What I have here now is, pretend these don't exist. You know, because we divided by 7, so I really don't have this anymore. Ooh, no, I got that parenthesis. I got to put that back in there. So this is what I really have, right? So I want to turn this into a log question. Log. It's all about that base. About that base. Yeah. All about that base. Well, I don't know what happened there. So anyway, so 2.4, and then these two things switch. In this case, it's 3,200 divided by 7. See, I don't like using my calculator on those intermediate values. You never, ever, ever want to round until the very end of a problem. I'm going to say that about 10 times today, I think. I'm just going to kind of remind you of that. So we're going to divide by 0.621, and then I'm going to type in all of this. So, log of, forgot already. Oh, of 2.4 of 3,200 divided by 7, 32, boy, that's a lot of twos, and divided by 7, and I'll take that, see, by the way, I didn't have to put it in that nice form, and I'll take that and I'll divided by 0.621. And I get 11.266. So, oops, let me get out of this. So I get t equals 11.266. Let's see if we need more than that. Right here, it's the nearest tenth of an hour. So time is equal to 11.3 hours. By the way, how's my hair look? Anyway, let's go. The value of savings account is compounded annually. Can be determined by this formula. See, that's not one of those ones where we have to use month. Now, I could, see, compounded annually is the same as the other formula, over once and then once, but I don't need those, right? So, whatever, there it is. This is what we're going to start with in 2001, and I want to know when will it be worth that much. Oh, 5%. Ooh, that's pretty good. Believe it or not, 5% is huge in investment. If you ever get an account that you can earn 5%, go for it. So we're going to use this. This is what our value is going to end at. This is what it's going to start at. It's 1 plus 0.05, 1 plus the rate, raised to the time. So I still need to, and by the way, they could have just said doubled your money because we're really going from 5,000 or 1,500 to 1,500 to 3,000. So double. That's a 2. So really what I have here is 2 equals 1.05 to the t. Now I'm going to rewrite it using log. So log base 1.05 of 2 is equal to t. So let's see how long it takes me to double my money. So log 1.05 of 2. 14.206. So t equals 14.206. So let's see. You got to be careful the way they ask us here. What is the first year that the account will be worth $13,000? So what is the first year? Well, it's in 14.2 years. So if we're in 2001 and I add 14 years, and I add 14.2 years, that'll be 2014.2. So the answer is in the year 2014, it will first be worth $3,000. And if that's behind my head, I apologize, but that's all I wrote. I told you what I wrote. You should write a little sentence at the end of a word problem. Us teachers like that. Mostly we just like to make you do more work. We're evil, evil. When I have my evil face, nothing brings me back to my pleasant face more than Brewer's coffee. The delicious aroma and taste. Whatever. Commercial's over. Let's go. So we've got 7.5%. If a home costs $42,000 in 2001, in what year will this home have doubled? Doubled. Doubled. So I want it to be worth $84,000. That's doubled. It is now worth $42,000. We got an interest rate of 7.5%. That's 0.075. And we're going to raise it to the t. All right. Well, divide by 42,000, I just get 2. 1.075 to the t. Let's write this in log form. It's all, you know, it's all about that base. 1.075, these two switch of 2 is equal to t. So basically almost the exact same problem we just did. Control log 1.075 of 2. 9.584. So t equals 9.584. We started in 2001. So if we add that, that gives us 2010.584. So what's the question says? By what year will this home have doubled? By the year year 2010, the home will have doubled in value. Sorry about my handwriting. I have no excuse other than bad penmanship. All right, so a new boat will decrease in value. So if we're going to decrease in value, we have to be subtracting off the interest rate, which is why we're subtracting off right here. 8% per year. And let's see. Let's just get all the stuff we got. So we're going to start at $40,000. We want to figure out when it ends up being $18,000. Now, can't be a monkey, right? If this thing's going to go down in value, so its current value is $18,000. That's what goes on the left side of the equation. It started at $40,000. Remember, if you're subtracting here, then this has to be the larger number, and its depreciated value goes to the left side. So just be careful with that. 1 minus 0.08 to the t. And let's see, we're going to divide by 40,000. This goes. Let's see, get rid of 0. 0, 0, 0. So I get 18 over 40, which is the same as 9 over 20, is equal to 1. Oh, wait, hold on. We're subtracting. So 0.92 to the t. Now, you don't really have to put this 0.92. As a matter of fact, I'll show you on the calculator. I don't have to put 0.92 in. That I can do it either way. But it makes it easier when you're doing this. Log of 0.92 of 9 over 20 is equal to t. So when you come over to your calculator, let's say you were not smart enough to figure out that 1 minus 0.92 is. So down here you'd put in 1 minus 0.08 of 9 divided by 20. I'm going to guess it's going to do the math for us. Nope. Now, you'll see that it's the same as this, 0.92 of 9 divided by 20. Same answer, 9.57 years. So, t is equal to 9.57 years. What's the question say? Find the number of years until the value is both worth this, $18,000. Round answer to the nearest tenth of a year. So t equals 9.6 years. Done. During surgery, a patient must have at least 40 milligrams of an antibiotic in his system. The amount of the antibiotic present is K hours after the administration of 100. This is the initial amount. Is given by this. That's why this is the initial amount right here. And there's my depreciated value. How many hours to the nearest tenth will the nurse have to administer another dose of this antibiotic to keep the level high enough? Well, what is high enough? It has to be at least 40. So our end result is it has to be 40. So 40 equals 100 milligram dose to start with, 0.508 to the K. That's the formula. So what we want to do is figure out how much time K, I don't know why they use K, probably for Kraus. Oh yeah. Anyway, how much time K before it goes down or depreciates. Notice this is below 1, right? So it's going to go down in value. Divide by 100, so I get 4/10 is equal to 0.508 to the K. I just divided by 100, by the way, and 40 divided by 100 is 4/10. I could have put 2/5 there, but I thought I really would have thrown a few of you. It's all about that base, not that base. Log 0.508 of 4/10, or 2/5. I'm going to put 2/5 in the next one because it's less typing, is equal to K. So we go over here, we go control log. I already forgot what it was. 0.508, 0.508 of 2 divided by 5. 2 divided by 5 is the same as 4/10. 1.35 hours. So K equals 1.35 hours. How many hours to the nearest tenth? So K equals 1.4 hours. So after about 1.5 hours, she'll have to administer it. I'm not sure I'd wait that long. And I'm not sure I'd be rounding when it comes to medicine. Not a good idea. A basketball is dropped from a height of 9 feet. Each time it bounces, it returns 65% of its previous amount. That's why this is 65%. That's the depreciated amount. Where n is the number of bounces. Find the number of bounces it will take for the ball to reach no more than 1.5 feet. So this is our ending amount. 9 is our starting amount. So we want to figure out how long it takes or how many bounces it takes before we can get to 1.5 feet. We're starting at 9 feet. You're getting 65% and times the number of times. So divide by 9. Divide by 9. I don't know what that is. I think it's 0.166666666, but doesn't matter. Maybe it's 0.016666. Anyway, now it's bothering me. I gotta know. 1.5 divided by 9. There it is. 0.166. I was right the first time. Doggone it. Okay. So anyway, now basically this stuff doesn't exist here. I've got a base. I've got an exponent. So I'm going to turn it into a logarithm. Log of 0.65 of this fraction, 1.5 over 9, is equal to n. All right. Log 0.65. Ooh, that would be really bad if I forgot the decimal. Of 1.5 divided by 9. 4.15. So n equals 4.15. Now, this is going to be a tricky question. So the question says, find the number of bounces it will take for the ball to reach a height of no more than 1.5 feet. So on its fourth bounce, it wasn't quite enough to be under the 1.5. So the answer to this question is actually it would take 5 bounces. Now on that fifth bounce, it would be really far below the 1.5. But after the fourth bounce, it wasn't quite enough because it was off by just a little bit. So we needed a fifth bounce. So 5 bounces. Tricky question. Don't fall for that one. A super bouncy ball is dropped from a height of 12 feet, and each time it bounces, it rises to a height of 80% of the height from which it was fell. The height h can be determined by this formula, and we want at most 2 feet. At most is the same as no more than. So it can't go over 2 feet. So we're going to do the same thing. 2 is equal to 12.8 to the x, where x is the number of bounces again. Divide by 2, or divide by 12. So I get the natural log, or the log, 0.8 of 1/6 equals x. So the log of 0.8 of 1 divided by 6 equals 8.209. So 8.209 is equal to x. Again, after 8 bounces, it's going to go up slightly higher than 2 feet. So the answer is 9 bounces. Moving on. The Richter scale measures the magnitude R of an earthquake. It is defined by that formula where E is the energy in kilowatt hours released by the quake. The 1933 quake in Japan measured 8.9 on this scale. In scientific notation with 3 significant digits, how much energy was released? So R is the magnitude. What are we looking for in this one? So I believe we're going to put in 8.9 here for R. That's the magnitude, and that was 8.9 on the Richter scale, is equal to 0.67 log. Now, I'm not going to base 10 of 0.37e plus 1.46. So that's what we got, really. Now, I put the 10 in there. It wasn't in there. So I'm going to have to subtract this 1.46, and then I'm going to divide by this. So let's do this. 8.9 minus 1.46. I forgot the 9. I wonder why it's doing that. 8.9 divided minus 1.46 is 7.44. So I get 7.44 is equal to 0.67 log base 10 of 0.37e. Yes, I don't like zeros in front. Divide by 0.67. Divide by 0.67. So I get, it's going to be bigger. It's going to get bigger when you divide by, so divide by 0.67. You get 11.1044, 11.1044. Oh, my dog's making friends with the neighbors. 7 something is equal to log base 10 of 0.37e. Okay. Let me get out a different color. So now what I'm going to do is change the form. So 10, it's all about the base, 10, right? Here's the base. And now these two things are going to switch. Of 111.1047 is equal to 0.37e. And then my final thing will just be to divide by 0.37. All right. Wow, this is a complicated one. So it did say in scientific notation, right? So we're going to do this in scientific notation. So it's 10 raised to the answer, enter, divided by 0.37. So there's my answer. 343, and how many? 3 significant digits. So 3.44. So 3.44 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11th. That's how much energy was released. Holy crap. Oh, this one's just 5.8. So we're just going to do that same thing. So how is it going to change here? The only difference is same formula, but we're going to do that same math. So in this case, this is 5.8. So let's go through it. We're going to take 5.8, subtract 1.46, enter. Then you're going to divide by 0.67. So divided by 0.67. Get some number. That's our exponent. Then we're going to raise 10 raised to that exponent. And we divide by 0.37. Divide by 0.37. So you should be able to do that one on your own. 811,727. 811,727. But I only want to, well, I should probably write the whole thing down. 7274. 7274. So 8.12 times 10 to the 1, 2, 3, 4, 5, 6. 6. I hope we don't have another one of these. Okay, good. An exponential model. How many of these do we have? 19. Oh my gosh. An exponential model of growth is represented by that, where P0 equals the amount of the original population, and T is the number of years time elapsed. The population of the culture is 2,000 now, and is 4,502 years. Then what is the value of K? So 4500 equals 2,000 times 10 to the K times 2. Or divide by 2,000. Divide this by 2,000. So let's see, 20, what was that, 2.5? I don't know. 45, it doesn't matter. 45 over 20 is equal to 10 to the 2K. Now we're going to log both sides. It's all about say base. So it's log base 10. Ooh, that's weird. Of, 45 over 20 is equal to 2K. And then we just divide by 2. So log base 10. I didn't have to put that 10 there. Of 45 divided by 20 equals, and then we divide by 2. 0.176. So K is equal to 0.176. Oh, they don't tell me to round? Oh, man, you got to write the whole thing out then. 09125. 09125. At least 6 decimals is good. Moving on. Same thing. What's the value of K? So now we're going to start with 2,400 is equal to 1,500 times 10 to the K times 2. It's basically the same problem. Oh. So divide by 1,500. And we get 10 to the 2K is equal to 24 over 15 log base 10 of 24 over 15 equals 2K divided by 2. Oops. Don't need you. Glad you're still working now. Control log base 10 of, don't remember, 24 over 15. 24 divided by 15, enter, divided by 2. K is equal to 0.102059. K is equal to 0.102059. Is that the same thing? Nope. The amount of money after, so now we're going to talk about compounding things. The amount of money A, so this is how much money we're going to have. We're doing it quarterly, so that's going to be a 4 because it said quarterly. Our interest rate is 7, so I remember, or 7%, so remember that's 0.07. And we want to figure out how long it will take to raise up to $2,500. Oh, how long will it take $2,500 to become $4,500? So our end result is $4,500. We're going to start with $2,500. And to that, I'm going to put it into 1 plus 0.07 over 4 to the 4 times t. Okay. We're going to divide by 2,500. So what I really want to know is what is 1 plus 0.07 divided by 4? 1.0175. So I get 0175 raised to the 4t is equal to 45 over 25. Now it's all about that base, so log base 1.0175 of 45 over 25 is equal to 4t. Then divide by 4. And that's what I'm going to put in my calculator, chillin'. So the log of the answer of 45 divided by 25 is divided by 4. It will take 8.470 years. T equals 8.470 years. To the nearest tenth, it will take approximately 8.5 years. Moving on. Same problem. We're still doing it quarterly. 9% interest rate. We want to get to 7,000, so it's going to be the same thing. 7,000 is equal to 5,300. 1 plus 0.09 over 4. We're still doing it quarterly to the 4t. Divide by 5,300. And it's all about that base. So now I'm going to do a log of 1 plus 0.09 over 4. I'm just going to figure out what that is when I go to it. Of this 70 over 53. I'm going to cast out those zeros. Is equal to, oops. What am I doing that for? I got an eraser. Of is equal to 4t. And I divide by 4. Divide by 4. So I take out my calculator. So 1 plus 0.09 divided by 4. I just want to figure out what that is. So control log of that answer of 70 over 53. 70 divided by 53 equals divided by 4. 3.125 years. So t equals 3.125 years. My final answer, round to the nearest tenth, t equals 3.1 years. All right, now we're going to change the problem up, sort of. We're going to go semi-annually. Semi-annually is twice a year. So we're going to take 3,600. We want it to make 5,200. So 5,200 is equal to 3,600. 1 plus, what's our interest rate? 9%. 0.9, compounded semi-annually. So that's twice. Raised to the 2t this time. Now it's 2t because still use n as 2. Divide by 3,600. Get rid of zeros. So I get, now I have an exponential. I'm going to turn it into logarithm. So log of, this is the base. Remember, it's this is, and this is the exponent. So log of 1 plus 0.09 over 2 of 52 over 36 is equal to 2t. Divide by 2, and I divide by 2. Next, I'm going to do the next one exactly out so you can see it. It's just kind of a pain in the neck with these calculators, or with these strange numbers. 1 plus 0.09 divided by 2. So log of that number of 52 over 36, 52 divided by 36, enter, divided by 2. It will take 4.177 years. So t equals 4.177, round to the nearest tenth again. T equals 4.2 years. All right. try to do this one a little bit slower. Maybe this will make more sense. We're still doing it semi-annually, 7% interest. We want a growth up to 4,200, and we're starting at 2,700. So we're going to 4,200. All I'm doing is plug that in for AFT. My principal amount was 2,700. 1 plus my interest rate is 7%, so 0.07. And we're doing it semi-annually, which means twice a year. That's the N. N is 2, N is 2. So 2t. Now, I'm going to divide by the whole side by 2,700. Those zeros go. So what I end up with is 42 over 27 is equal to 1.03. Nope, that's not right either. Well, let me just add this up. 1 plus 0.07 divided by 2. 1.035. Oh, I was right. 1.035 to the 2t. So I've just added all this stuff up here, and that's really equal to this 1.035. This is an exponential. Here's the base. So I'm going to turn it into a logarithm. So log of that base, 1.035 of 42 over 27. Don't give me that decimal. Just leave it like that. Is equal to 2t. Divide by 2. Divide by 2. So the log of 1.035 of 42 divided by 27 equals, and then divide that by 2, and I get 6.421 years. So t equals 6.421. And I think they said tenth again. So t is equal to 6.4 years. Again, you don't have to watch all of these. You just need to slather. We only got 3 left. The amount of money A after t years with principal P. Oh, now we're going to do it annually. Oh, to the nearest tenth, how long will it take the sum of a money to double if it's invested 12% and it's compounded annually? Whatever. So it's not telling us anything. It's not telling us anything. So we can make it up. Let's say we're starting with amount of that's $100, and if it's going to be doubled, don't we want it to be $200? So we'll start with 100 and go to 200 because they didn't tell us. We just want to know how long it'll take to double. I could pick any number I want. So you'll see how this plays out in a minute. So we're going to end up with 200. We're going to start with 100. And then it's 1 plus 0.12, that's bigger than 10, over 1, so I don't really need that, to the 1 times t, which I don't need that either since it's compounded annually. So I divide by 100, I get 2 equals 1.12 to the t. I just added these up. Okay. It's all about that base. So log of 1.12 of 2 equals t. And this is going to tell me how long it takes my money to double if I have 12% interest. So control log 0.12, oops, 1.12, and double. 6.116. So t equals 6.116 years, round to the nearest tenth. T equals 6.1 years. How long will it take a sum of money to double if it's invested at 9% interest compounded annually? So we'll do the same thing, but now I know I'm just going to have this and this are going to make a 2. So 2 is equal to 1 plus 0.09 divided by 1 to the 1 times 2. Now, I could have put the 200 here and the 100 there just like I did in the last problem, but it's the same thing. So log of 1.09 of 2 is equal to t. So it's basically the exact same thing. I don't even have to do much work. Just go here, change this, and I'll change it from that to a 0.09, 1.09 double. It'll take 8.04 years. So t equals 8.0 years, because it's around to the tenths. And last but not least, savings count. Oh, now we're going to do compounded continuously. All right, so compounded continuously. There it is right there. Compounded continuously for y years. Solve this equation for y. So what I have is b equals p e to the ry. Now remember, this is not a letter or variable e. It is the base e, 2.7172 or whatever it is exactly. We want to solve for p. So we want to solve for, let me tell you what we're going to solve for. I'm going to keep it in black, just to kind of make it a little bit easier to look to see what we're going to solve for. We're going to solve for this in black. So let me go back. Every time I do it, I'll change that color. So the first thing I'm going to do is divide by p. Divide by p, because you got to get the weird thing alone. So b over p is equal to e to the r y. Now, the only way to get this y out of an exponent when I have exponential notation here, or when I have an exponential function, is to use logarithms. Now, this is the special case with e. I have to use natural logarithms. So I'm going to natural log to both sides. It's all about the base. So natural log of e. Remember, we don't even actually need the e, but and these two switch places, of b over p is equal to ry. Oops. So I was going to write the y in black. Ry. I still want to get y by itself, so I'm going to divide by r. So the natural log, I don't know the e, of b over p all over r. Now, if you want that e back in there because it makes you feel better, just put it back in there. Okay, equals y. All right, if the initial interest rate is $1,200, if the initial balance is $1,200, that's p, how many years would it take to arrive at balance? We're going to end up with $3,200 at a rate of 8%. All right, so what we're going to do is just kind of throw all these things in here. So the natural log of, now let's see, b is my ending amount, $3,200. P was my initial amount, which was $1,200. All divided by my rate, which is 0.08, is equal to y. So I'll just type that in. Natural log of 3,200. So we're going to do the natural log of 32 divided by 12. I can get rid of the zeros. Enter. Divided by 0.08 equals 12.26 years. So y is equal to 12.26036. 036 years, rounded to the nearest tenth of a year. So y is equal to 12.3 years. Make sure your answers make sense. Kids, that's all there is to it. I did the same problems basically over and over and over again, just trying to show you how to use logs or exponents or exponential functions in order to arrive at solutions. I hope you enjoyed your stay with me. It was fun. Goodbye, kids. Hit the subscribe button.